All right, so today we're going to get into talking about law of sines and law of cosines. Um, and law of sines and law of cosines is a way for us to take these right triangle ideas and apply them to any triangle. What are called oblique triangles, right? Anything that's not a right in geometry is called oblique. So, law of sines is where we start. And the law of sines, again, we're going to apply this law to our non-right triangles. And so what it does is it takes our angle measures and relates it to the opposite side lengths. So just to get into it, the law of sines says this. It says that if we take the sine of, say, angle A, and compare that to the opposite side length, so call it A, then that comparison, that ratio, should be the same as doing the same thing for the other angles and their opposite sides. So the sine of angle A compared to the opposite side length is going to be equal to the sine of angle B compared to its opposite side length, which is going to be equal to the sine of angle C, which is compared to its opposite side length. So we've got three ratios that we can set equal to each other, cross multiply and solve because it's a proportion, and be able to find a missing angle measure or missing side length in a non-right triangle. And that's helpful because we have no way to do that. We have no way to finding a missing angle measure or missing side length in a triangle that is not a right triangle. We don't have things like sine, cosine, and tangent for non-right triangles. So this law kind of helps us out. So really it's just a matter of setting up these ratios, setting them equal to each other, and cross-multiplying and solving. So for example, in this first one, we've got triangle ABC here. And we want to solve it, right? It's like solving a right triangle. We want to make sure that we have all the missing side lengths and all the missing angle measures. And right now we've got the length of side A, and we've got the measure for angle A and angle B. Well, first and foremost, angle C becomes pretty easy. Just because it's not a right triangle doesn't mean that the angles stop adding up to 180. So, to find angle C, we can just take 32 plus 81.8 and subtract that from 180. Okay? When we do, the measure of angle C just ends up being 66.2 degrees. So done with that, right? But now, if we want to find the length of B, side B and side C, we've got to use this law of sines. We can't use Pythagorean theorem. This is not a right triangle. So we can go the sine of A over the length of A equals the sine of B over the length of B. And that'll help us find the length of side B, because we know we know angle A. Angle A is 32 degrees. The length of side A is 42.9 centimeters. We know the measure of angle B, which is 81.8 degrees, and we can cross multiply and find the length of B. So now it just becomes a bunch of button pushing in your calculator. We got to take 42.9 times sine of 81.8, right? That is going to get you roughly 42.46. And then we're going to take, B sine of 32, and then we've got to divide both sides by sine of 32. So now when you do the 42.9 times the sine of 81.8, you don't want to round that off and just type in 42.46. Go ahead and leave that decimal in your calculator so that you don't have to worry about rounding issues. Okay, so when you take that decimal and divide it by the sine of 32 degrees, you should get that the length of B is 80.13 centimeters if you round it to the nearest hundredth. Okay? And then to find the length of C, it's going to be the same thing. Now, if I were you, I would continue to use angle A and side A since those two things were given to us. Otherwise, you run the risk of using something that you found, and if you made a mistake, it messes up all your other calculations. So, sine of 32 over 42.9 is going to be equal to the sine of C. No choice but to use 66.2 here over C, and then we're going to cross multiply and get C. That means taking 42.9 times the sine of 66.2 and dividing it by the sine of 32 degrees, which you should get as 74.07 centimeters. And now we've got everything. We've got C, we've got the measure of angle C, and we've got the length of side B. Okay? And that's all there is to it. A little bit of work, a little bit of writing out, but not too terribly difficult, I hope. Okay? Try a different one. And again, it doesn't matter what angles we're missing, what sides we're missing. What we're really looking for is what angles and opposite sides do we have to put together to use in our proportion. So here we've got angle A, angle C, and side C. Well, angle B is really, really easy. Just take 180 minus, and then add up angle A and angle C. And subtract those. And you get 48.6 degrees. Okay? So, since we know angle C and side C, use that ratio in your proportion to find all the other side lengths, right? So, let's see, we've got this angle A, so why don't we go find A really quick. And then we're going to cross multiply this, and A is what you get when you take 25.3 times the sine of 28.8. Make sure you hit enter on that, and then hit divided by, because we're going to divide by sine of 102.6. And that will get you 12.49 inches. And then to find B, same thing. So we're going to take, again, sine of 102.6 over 25.3 equals, let's see, we found A, so we got to use B. So sine of 48.6 over B. And again, no choice but to use the angle that we found for B, because that's the formula. So cross multiply 25.3 times the sine of 48.6, and then divide by sine of 102.6. And you get 19.45 inches. Okay? And there you go. Now, how can we use this? Well, it keeps us from being forced into creating a right triangle situation. Right? So, for example, Kurt Daniels wishes to measure the distance across the Gasconade River. Right? And so there you go. He determines angle C at 102.9 degrees, angle A at 31.10 degrees, and B at 347.6 feet. Find the distance across the river. Well, this is side A. Let's use a different color there. This is side A, this is side B, this is side C. Okay? So we've been given, let's see, so we want to use, so we're not trying to find everything. How about we just set up a proportion and figure out what we need if we're missing anything, right? And I want to use the sine of angle B because that's what allows me to use the length of side B. right? And that's what I want. I can't find the lengths of these sides unless I have angle measures to go with it, okay? We've got angle A and we've got angle C. We want to find the distance A. So I have to use sine of A over A. And then since I've been given the length of side B, then I want to use angle B. Now we don't know what angle B is, but I can find that pretty easily. That's just your adding the angles up and subtracting from 180, right? So 102.9 plus 31.1, subtract that from 180 and you get 36. So this is 36 degrees. So now I can start to fill in my formula. So I can go sine of 31.1 over, don't know A is what we're trying to find, and then the sine of 36 degrees over the length of B, which is 347.6 feet. Now we cross multiply. So 347.6 times sine of 31.1. And then divide that by sine of 36, right? So we're going to cross multiply. So that's why I'm multiplying these guys together first and then dividing by the sine of 36. And so we get 305.46 feet. That's the distance across that river. Okay? All right. Next example here. We want to find the height of this building, right? Well, we've done that before. Find the height of this building puts us, well, you see here, it puts us in a right triangle right here, where that angle is 48 degrees. Now, unfortunately, we don't have any distances. We don't know what this distance is right here. We don't know what this hypotenuse distance is, and we definitely don't know the height of the building, or we wouldn't be asking the question, right? There's a bigger right triangle right here, but we're kind of in the same boat, right? Where we don't know this distance, we don't know this hypotenuse, and we don't know the height, even though we have this angle measure that we could use. So that's not going to help us either. So instead, we start thinking, well, if I have an angle measure and one side length, then I can go find any other side in the right triangle. So if I had, say, this hypotenuse, then I'd be in good shape. Well, now we're talking about finding a length in this non-right triangle that becomes the hypotenuse for the right triangle. Right? So we can start thinking about law of sines. Now, we are going to need more than just one angle in this non-right triangle. Well, you got to think back to geometry. If this angle is 48 degrees, then we can find this one, right? Those guys are a linear pair. They have to add to 180. So that means that this angle is 132 degrees, right? Now we've got two angles in this non-right triangle that we can add up, and they have to add up to 180, right? So all three of them. So that means that this missing angle up here is going to be 13 degrees because I added 35 and 132, and I subtracted all of that from 180. Okay? All right. Now, how does that help? Well, I'm still looking for this side. So I'm looking for the side opposite the 35 degrees. So if I go sine of 35 over x, that has to be equal to, well, I know this side length, and I know its opposite angle. So I can go sine of 13 over 150. Now we cross multiply this. We got to take sine of 35 times 150. And then divide that by the sine of 13 degrees. And we get 382.47 feet. So that becomes your hypotenuse of this right triangle. Now if we want to find the height of the building, and we've got this angle right here, we've got opposite hypotenuse, so we can go sine of 48 equals x over, I don't want to call that x again. How about y? We can let the height of the building be y, or h, I guess, would make sense as well. So anyway, y over what we found for that original x, which is 382.47 feet. Now hopefully you did not delete that from your calculator, that entire decimal, because we need to use that. Remember that if y is up high, multiply, so take that big decimal, 382.46744914, and multiply it by the sine of 48 degrees, and we find the height of the building to be 284.23 feet. Okay? Just a couple of quick applications of sine. I know by the time we're done, this picture looks kind of crazy, but hopefully you're able to follow along through that. Okay? If not, definitely come in and sit down and we'll walk through it together to make it make more sense. All right? Now, with all of that, we can use this law of sines to help us find the area of a triangle, the area of a non-right triangle, right? Again, right triangles, we can use the sides, the two legs, as the base and the height. So just do 1/2 base times height. But in a situation like this, where it's not a right triangle, and we don't have an easy way to find the base and the height, then we can kind of start thinking about this in terms of this law of sine formula, right? There's a different kind of formula for the area of a triangle. Okay? And this has its basis in the law of sines. This is as far as I want to go with it. Just be familiar with the formulas and be able to use them. Right? So 1/2 times, well, length B and C, and then times the sine of A. Right? So depends on what information we've got. Or we can take the length of A, side B, and multiply it by the sine of the angle between them. I think that's what you're going to find out of all of this, and then 1/2 of that. Right? It's going to be two side lengths and the angle between them that we need to take the sine of, that we have to multiply together and then take 1/2 of that. Okay? So, for example, here, if you want to draw the triangle, we can. Draw it however you want. We don't know what it really looks like. Label it A, B, C. That means that this is side B, this is side A, this is side C. Now we've been given the length of A, the length of C, and angle B, which means that we can jump right into the formula and find the area by just taking 1/2 times the length of A, which is 34.0, times the length of C, which is 42.0, times the sine of 55 degrees, because that's the angle in between them. Well, no problem. 34 times 42 times the sine of 55, then divide that by 2, and the area is 584.87 feet squared. Done. So it's the two side lengths plus the sine of the angle, not plus, the two side lengths multiplied together, then multiply it by the sine of the angle between them, and then divide it by 2. Okay? Another one. Again, sketch just a generic triangle, go A, B, C. And so we've got, let's see, this is going to be B, this is going to be A, this is going to be C. We've got A and C, and we've been given the angle measure of B. Right? No problem. So again, not even that the labeling the sides is all that important, other than just making sure that the two side lengths you've got goes along with the angle that's between them. So now we take 1/2 times 9 times 12 times the sine of 124 degrees, right? 9 times 12 times sine of 124 degrees, and then divide that by 2, and you get 44.77 feet squared. Right? That's it. All right? One for you to do. Right? So sketch a triangle, label it, and then make sure that you've got the two sides that you need and the angle between them. If not, then we might need to do some more work. So think about that for a second. Stop the video, see if you can't figure it out, and then start it back up and see if you're right. All right, so if we sketch a quick triangle, so A, B, C, this is side B, this is side A, this is side C. Well, we've been given angle A, which is 24 degrees. We've been given angle C, which is 52 degrees. We've been given side B, and that's it. That means that we need to either come up with side C or side A, right? We're missing a side. Well, in order to do that, we've got to know angle B. Since we know side B, we're going to have to find angle B, and then we're going to use the law of sines to find either side A or side C, and then use that in an area formula to find the area. So, in other words, angle B is just going to be 24 plus 52, subtracted from 180, right? So it's going to be 180 minus 24 plus 52. Which is going to be 76. Subtract that from 180. And you get 104 for this angle up here. Okay? So that means we've got to take the sine of 104 over 27.3 and set that equal to, and it doesn't matter if you find A or C, either one will work. So it really just becomes kind of dealer's choice. And I mislabeled this, didn't I? So this opposite side should be A, this one should be C, but it doesn't matter. It still doesn't matter which side you find. So we can go find A, so go sine of 24 over A. Now you're going to cross multiply sine of 24 and 27.3. Then you're going to divide that by the sine of 104. And so A is 11.44 centimeters. So now we've got A. Now to find the area, we're going to use side A, side B, and angle C. So the area of this triangle is 1/2 times, and we've got B, 27.3. We've got A, and it's rounded, so try not to use the rounded guy. Use whatever's sitting in your calculator right now. And it's times the sine of the angle between them, which is 52 degrees. And now we just multiply all that together. So 11.44 times 27.3 times sine of 52. Divide that by 2, and I'm getting an area of 123.09 centimeters squared. Okay? And that's it. Done. A little bit of work. Hopefully not real hard, though. Just a matter of setting up the formula that you need and then figuring out what you have to plug into it. Okay? All right? Homework sitting out in Canvas. Go ahead and give it a shot. We'll talk about questions next time.